studying surface active agents, or surfactants for short. These are compounds found in substances all around us, from cosmetics to certain foods, detergents and soaps. Now, surfactants may be commonplace, but what they do, well, it's pretty weird. Surfactants are molecules where one part loves water and the other part doesn't. This allows oily substances to mix with water as each surfactant part sticks to its preferred substance. This dual nature also reduces the surface tension of water, so it mixes more easily with air to form stable bubbles. On a wet surface, surfactant molecules sandwich water molecules in layers, making that surface even slippier. OK, it's test time. Question 1. We've learnt that surfactants are two-faced molecules that mess with the way substances interact. But what good is all that in the shower? The surfactant in shampoo allows water to mix with grease and carry it away. That's because your friends keep pouring it on your head. But at least your hair will be nice and shiny. Question 2. What happens when water and air is mixed with a surfactant? Mum's away and Dad has imprisoned the noisy rascals in a foam tower.
It's literally touching the ceiling.
Yes, thanks to the surfactants in soap reducing water tension, air easily mixes in to form stable bubbles. It's just a shame they're not soundproof. Finally, question 3. What effect can surfactants have on a wet surface? Here's a clue. When the water molecules on his slip and slide are trapped between the soap's surfactant molecules, the resulting layers can easily slide over each other, making it super slippy, turning a regular Joe into a neighborhood legend. Take care, serious injuries have occurred on slip and slides, particularly involving bigger kids and adults. But him, he's doing fine. Class dismissed. A vision of futuristic efficiency for 20th century sci-fi writers like H.G. Wells, the moving walkway has actually been with us for over 100 years. So you'd think we'd have figured out how to use them by now. No, not like that. Yeah, now you're just being silly. It's very complicated. You walk on, amble along a bit, and walk off. But how do they work on a scientific level? A moving walkway is a wide rubber belt or continuous sequence of metal pallets powered by an electric motor. The motor uses electrical energy to transform rotational motion into continuous horizontal motion in the walkway. Typically, walkways move at around 1.4 miles an hour, about half the average walking speed of a healthy adult. Stepping onto the walkway can produce an abrupt change in velocity, so moving handrails help with balance. They're supposed to make pedestrian travel more efficient, and yet studies have shown that they actually might be slowing us down, because as soon as we step on that belt, we instinctively tend to stop or walk slower, ultimately clogging up the way for other users. But this isn't quite what I meant. These walkways take skiers straight to the ski slope. But if those skis make contact with the static ground, friction can drag it out from under you, making the ride not so much fun. Now, handrails can help, but they also need to be on a continuous loop, which means they don't slow down or stop at the end. They just keep going round. Did you know in Toronto there's a walkway that travels at 4.5 miles an hour? That's 3 times faster than the average. So that would have been a bit more like this. But in some ways, that's not really even the fastest walkway. This is.
Level 7!
Same mechanics, but beware, that velocity change doesn't just happen when you get on.
You alright?